Alrighty, here are the long promised and finally delivered notes on fossil fuels. And I hope you enjoy this cartoon because it makes me laugh way more than it should. All right, so let's get started talking. So, first, let's talk about the combustion of fossil fuels and what that involves. So, here is a definition of combustion as well as kind of a chemical equation, kind of in diagram form. So, combustion is when you burn fuel with oxygen, and that is going to create carbon dioxide, water, and energy. And it's that energy that then ends up getting used to produce electricity or to power a motor vehicle or any of the things that we use energy for. Then notice that when you burn fossil fuels, you always get CO2 as a byproduct. And remember, CO2 is a greenhouse gas that helps to absorb and retain heat in the atmosphere. Another note, the reason why fossil fuels are combustible is because they are all hydrocarbons, meaning that they contain mostly carbon and hydrogen in their molecules, which means that they store a very large amount of chemical energy. That's part of what makes them such good fuels. We say they have a high energy density, meaning that per relative mass, they have a lot of energy packed into a relatively small mass. So if you look at this diagram, this shows the energy density of various fuels. You'll see wood has a pretty good energy density, coal has an even better one, and something like natural gas has, almost between 2 and 3 times as much energy per unit of mass as something like wood does. So let's talk about how electricity is generated using fossil fuels. It is the traditional model that we've been looking at. So you burn fossil fuels to generate heat. Here we see coal being first crushed and pulverized to make it into small uniform sized particles that then get thrown into a boiler and set on fire. When they are set on fire, they release a few things. They release smoke, which we'll talk about when we talk about the environmental impacts. Those go up a smokestack or a flue, which is a fancy name for a chimney. But the heat that is produced is used to turn water into steam, and that water, which is now steam, has kinetic energy, and that is going to be used to turn a turbine, and that turbine turns a generator, and that is what produces electricity. A few notes. You can actually keep recycling the water that you turn into steam as long as you use a condenser, which is a device that you're using to cool the steam back down so it turns into liquid water. This can often use an outside source of water to absorb the heat. So this water is cool as it goes in. As it comes out, it has some of the heat from the steam, which allows the steam to cool down and become liquid water. Then this water needs to be cooled before it can be put back into a local body of water, because otherwise it can cause thermal pollution, which can kill aquatic organisms. So, first, real quick, let's talk about the energy transformations that are happening here. So, you start with chemical energy in the form of the fossil fuel. When you burn it, the fossil fuel, that turns into thermal energy, which is then turned into kinetic energy in the form of the steam that's moving, that then turns the turbine. And then finally, at the generator, you convert that kinetic energy into electrical energy. So keep in mind the energy transformations that are happening. So let's talk about how fossil fuels are taken out of the ground. And that's what extraction means. Extract means you take out and kind of purify, in case that term is unfamiliar. So, real quick, let's talk about types of coal because there's different types of coal. There's peat, which we talked about in types of fuel. It's called pre-coal. It has the lowest heat content. It is not useful for generating electricity. There is, once you expose heat to heat and pressure over time, it becomes lignite. This is the softest coal with the lowest heat content. It's also not as useful for electricity generation. If you take that lignite and you expose it to more heat and pressure, then it becomes bituminous coal, which starts to be some coal that can be used for electricity generation. It's softer coal and it tends to have a higher sulfur content, which will become relevant when we talk about air pollution generated by burning coal. But the best coal by far is anthracite. It's also the rarest. It's a hard rock, so it's a hard mineral with high heat content. It's the rarest to find, but it's the best to use for generating electricity because it has a lot of, it's very energy dense, basically. How do we get coal out of the ground? Well, we've talked about mining before. So there are multiple ways that coal is extracted. There's surface mining, although most areas where you can mine coal with surface mining have already been mined out. There's underground mining, where you can get at seams of coal that are underground. And there's mountaintop removal, which is basically exploding the peaks of mountains and getting as much coal as you can out of them. Here is on this diagram mountaintop removal, where you're exploding the old outline of the mountain, and then you push all of the non-coal kind of waste product into a nearby valley. So it flattens out these mountains. But it allows you to get a lot of coal that otherwise would be more difficult to extract. How are oil and natural gas taken out of the ground? Well, in traditional oil and natural gas extraction, you're going to drill a well into the ground, as you see in this GIF right here. The oil is usually under pressure, and so it rises to the surface by itself. That's kind of represented by this gushing oil well releasing fluid. Um, Once the pressure lessens and that oil is no longer coming out, you can either pump water into the reservoir or you can pump in gas, which will increase the pressure. And this is that injector rig, which is injecting water or carbon dioxide or some sort of gas into the well to try and increase pressure and force the oil out. Natural gas is usually found in the same areas as oil and is produced from the same formations. On land, a lot of times that gas is piped to areas where it can be used, but with offshore drilling with ocean rigs, that storage and transport of natural gas can be problematic. So, unfortunately, a lot of it is just burnt at the well as a waste product, or sometimes it's captured and re injected into the well to maintain pressure. Before oil can be used, it needs to be refined. So that process is called cracking. What happens is you take oil and you heat it, and the lighter elements start to boil off, and then you can condense those. So let's say you take a barrel of crude oil and you start heating it. The first thing that's going to come off is going to be stuff like butane and lighter gas products between like 50 and 185 degrees. What boils off now is the components that are used for making gasoline. And then you see as you heat it more of these compounds will evaporate or boil off so that you can condense them later. And this is how oil is broken down into various components. So you can see, for example, where naphtha is released, where jet fuel is released, diesel and heating oil, heavy gas oil, and other heavier elements. This produces all of the various things, then products that we get from oil. Now, as oil sources have dwindled and it's gotten harder and harder to find oil, we've turned now to more non-conventional oil sources. These are formations where there is oil, but it's mixed in with other things, and it's hard to get it just by straight drilling through. This is also formations where material has not yet turned into oil. Some cases it requires a little extra cooking, but we'll talk about that in a moment. There are two major sources that we're using for oil. These non-conventional oil sources, they're called either oil sands or tar sands, and then there's a separate type of resource called oil shale. And there are two methods for taking them out. You can either strip mine these things, so dig them up from the surface and remove them and purify, or you can do what's called in situ, or you can think of that as on site. extraction, where you inject something into the ground and that allows you to get the oil flowing so you can pump it out. Now, I will point out that the type of oil that is released from these is not exactly the same as crude oil. Sometimes it has to be converted into something and it becomes a kind of synthetic crude oil. Tar sands, for example, contain a mineral called or an oil called bitumen. And this is the structure of tar sands. So notice they've got a lot of sand particles. Those sand particles individually are covered with water and they have some like fine grained elements in there. And that is all suspended in kind of this gooey bitumen semi solid oil. So if it's close enough to the surface, you can just start digging it up. And then here's the process by which that's converted into oil. You basically take it, you mix it with hot water that creates this kind of slurry that's then separated. So the sand that's in there settles out, then a layer of water settles out, and then finally you have this froth, which is kind of a bubbly mix of all the oils. And then you can remove that and you can purify it and add some various dilutants, which are going to make it from a semi solid oil into something more liquid. And that can be turned into synthetic crude oil. So it's usually mined using strip mining. Most of the tar and oil sands that we know about are found in Canada and Venezuela. Canada, for example, has done a lot of oil sand refining lately. The problem with that, though, is they've been strip mining across large parts of areas that tend to have like slow growing forest and stuff, and it causes really long term environmental damage. Oil shale is different from oil sands in that it is a solid rock that does contain some of what's called kerogen, which is another oil that can then be converted into like synthetic petroleum. When you heat it, it releases these hydrocarbons that can be used in place of petroleum products. So here you see actual oil shale, the rock, and here you see some extracted kerogen. The methods of extraction include hydraulic fracturing, which we'll talk about for a minute, and then some on-site or in situ extraction. So let's talk about fracking. Fracking, otherwise known as hydraulic fracturing, involves making fractures or cracks in the rock underneath the Earth's surface. So what happens is you drill down into a layer of oil shale and you pump chemicals into the ground that cause fractures in the rock. And then some of those chemicals will then allow gas and oil to flow out. They may dissolve them, make them a little easier to flow. Um, and then you can extract that material from the rock. We'll talk about the environmental consequences of this in a few slides. On-site extraction involves heating the oil shale until it produces a kind of oil called shale oil, which can then be pumped out of the ground. But I do want to point out one, they have to pump stuff in that creates a barrier to prevent groundwater from being contaminated. Here in this diagram, they're using ammonia. Then they use various methods to warm the rock, and that will convert the matter that's in there, the kerogen, into shale oil. But this process takes several years. So this is like trying to kind of rush the process of fossil fuel formation. And then once that's done, you can actually pump out oil. So, what are the environmental impacts of all of this? Well, obviously, combustion, as I said, produces CO2, and CO2 is a greenhouse gas that contributes to climate change. Here on this graph, what you're seeing is CO2 emissions from various fossil fuel combustion, though we'll talk later when we talk about climate change about how cement production actually helps as well contribute to climate change. So you see, we've had a lot of CO2 release from burning things. Here is coal, for example. It's the solid fuel. Liquid fuel would be some kind of oil, and then gas fuel, this would be like natural gas. But burning coal produces additional pollutants. So from the flue or the smokestack, you get not only CO2, but you get sulfur dioxide. This, when we talk about about air pollution, we're going to learn contributes to acid rain. It also produces nitrogen oxygen containing compounds, which these can be anything from NO to NO2 to other mixes of nitrogen and oxygen. So, as a general catch all term, we call them NOx's, and these can contribute to smog. And then particulate matter is released, little fine particles like fly ash that can be released in smoke that are also a contributor to air pollution. Then, burning coal also produces solid waste, what's left behind from burning the coal, things like ash, both fly ash and bottom ash. One of the processes that's used to try and remove some of the sulfur dioxide from the smoke that's produced from burning coal makes a sludge called desulfurization sludge. We'll talk about that more when we talk about how we try and remedy. Air pollution, but this stuff can contain harmful heavy metals, things like mercury, and those can be dangerous for the environment as well, especially since sometimes that fly ash spills out of its containment. So this was a big ash slide in 2008, where all of this black goo right here, that's all fly ash that leaked out of its containment area. Notice it's contaminating waterways. This is some sort of river or creek, and it contaminated a large area of land. Fracking has its own set of various environmental issues. For example, methane can leak into the air. It uses a lot of water because you mix water with various solvents that you then pump into the ground. Some of the fluids that are injected can be carcinogenic. That means they cause cancer. Or they're straight up toxic, and sometimes that can contaminate groundwater if they leak into the surrounding area. Some of the material that's flowing out can contain dangerous chemicals and including some radioactive material that then has to be disposed of. It can release what are called volatile organic compounds. These are things that evaporate quickly and then contribute to air pollution and can even induce some seismic activity. So, one of the first places where hydraulic fracturing was used was here in Texas in an area called the Barnett Shale. And there have been actually several earthquakes in Texas since they started fracking. Before that, we didn't really have much seismic activity. We were a pretty seismically stable area. Um, so there's some consequences there. And that is it for this set of lessons. The next one will be nuclear power.